Hello everyone, I'm MTAL Arslan. Welcome to the third lesson of our introduction to programming lesson. Today we will discuss what makes an good algorithm. Let's start. An algorithm must be very precise. It cannot have unclear instructions. Let me give you an example. When look at a cooking recipe, we often see instructions like 4 or 5 cups or how to taste. These are not precise enough for our algorithm. Also, instructions like cook until beans are soft are too subjective. This is why a cooking recipe is not an algorithm. A proper algorithm must have two important features. First, it must be finite. It means it needs to end at some point. Second, when it ends, it must either gives us the correct solution or tell us that it cannot find the solution. An algorithm should never run forever without stopping. And flowchart. Learn something about flowcharts. Flowcharts are very useful tools because they help us describe algorithms visually. There are four main elements in a flowchart. First, we have boxes. These show operations or actions. Second, we have arrows that show us which direction to follow. Third, we use diamond shapes for decision points, where we need to choose between different paths. Finally, we use parallelograms to show when we need the input or output information operation. And finding maximum score algorithm description. Let's look at the practical example. Finding the highest score in an exam with 50 students. To solve this problem, we need to store all the scores somewhere. We will use what we call an array. Think of it as a list of 50 numbers. We'll name this array score. We also need one more to keep track of the highest score we have found so far. We call this max. The basic steps are simple. First, we take the first student score as our starting maximum. Then we check if there are more students to compare. If there are, we look at the next score and see if it is higher than our current maximum. If it is higher, we update our maximum. We keep doing this until we have checked all students. Finally, we show the highest score we found. And algorithm improvement. To make our algorithm more precise, we need to solve two problems. How to know if there are more students and how to find the next score. We can solve this by using a count variable I, mean index. Here's how it works. We start by setting max to first score and I to 2, since we have already used the first score. Then we check if I is less than or equal to 50. If it is, we compare the score at position I with our current max. This new score is bigger. It becomes our new max. Then we increase I by 1 and check again. We continue until we have checked all 50 scores. Finally, we show the maximum value we found. Very easy. This algorithm is not hard. What's hard? Complex algorithm. Like this. The page shows us the flow chart of our maximum score algorithm. Let's follow the flow. We start at the top, set our initial values for max and I, then enter a loop. In the loop, we first check if I is less than or equal to 50. If yes, we check if the current score is bigger than max. If it is, we update max. Then we increase I by 1 and go back to check the next number. If I becomes greater than 50, we exit the loop and print our final maximum value. The arrows show us exactly how the program flows from one step to another. Let's try it and go. If not, go. Check. Not go. Check. Yes. Print max. Start. As you can see, start and end point. An example with numbers. This flowchart shows us finding the maximum score among 6 students. We start with the first score, which is 43. Then we check each score, 74, 65, 58, 82, and 37. Let's follow what happens. when we check 74, it's bigger than 43. So 74 becomes our new max. Then we check 65, smaller than 74, so we keep 74. When we get to 82, it's bigger than 74, so 82 becomes our new maximum. Last score, 37 is smaller than 82, so our final maximum stays at 82. The flow chart shows us each step of this process. And table representation. Another way to understand how our algorithm works is by using a table. This table shows us exactly what happens at each step. The first column shows us the count right. The second column shows if the score we are looking at is bigger than our current maximum, and the last column shows our current maximum value. For example, when I is 2, we compare 74 with 43, and since 74 is bigger, it becomes our new maximum. When I becomes 7, we stop because we have checked all 6. This table helps us track every change in our program. And let's look at something fun, a number guessing game. Here's how it works. One player thinks of a number between two limits. We call these the lower and upper bounds. The other player tries to guess this number. After each quiz, the first player gives a hint. They say smaller if the guess is too big, or bigger if the guess is too small. The game continues until someone guesses the correct number. This is a great example of how we can use algorithms in a simple way. And two different algorithms. Let's compare two different ways to solve our number guessing game. I explained it. Algorithm 1 is very simple. We start at the lowest number and keep adding 1 until we find the target. We start by guessing the lower bound. If it's not correct, we add 1 and guess again. We keep doing this until we find the right number. Algorithm 2 is smarter. We always guess the middle number between our current lower and upper bounds. If our guess is too big, we look in the lower half. If our guess is too small, we look in upper half. Second method is called binary search, and it's usually much faster. And binary search algorithm steps. Let's look at algorithm 2 in more detail. First, we set two variables. Bottom starts at our lower bound and top starts at our upper bound. Then we calculate our guess by finding the middle point between bottom and top. If the guess is our target number, we are done. If not, we update either bottom or top based on whether our guess was too high or too low. If our guess was too high, we set top to be one less than our guess. If our guess was too low, we set bottom to be one more than our guess. Then we try again with a new middle point. And it's the binary search flowchart. With flowchart algorithm, we start by setting our bottom and top values. Then we calculate our first guess as a middle point. The diamond shape shows our main decision point. Is our guess equal to target? If yes, we print answer and stop. If no, we have another decision. Is our guess bigger than target? If yes, we update top. If no, we update bottom. Then we go back and make a new guess. These arrows shows how we keep looping until we find the right number. And example with real number, we are looking for the numbers 19 between 1 and 63. Our first word is 32, the middle of 1 and 63. 32 is too big, so we know our number is between 1 and 31. Our next word is 16. This is too small, so our number is between 17 and 31. We continue this process. Second guess is at 24, 20, 18, and final 19. Each time we cut our search array in half, which makes this method very efficient. And table. Finally, let's look at the table that shows each step of our binary search for number 19. The table shows how our bottom and top values change, and what we guess each time. Start with bottom equal 1 and top 63, so we guess 32. Since 32 is too big, our new top becomes 31. We keep adjusting until bottom and top become 19, which means we have found our target. This table helps us track exactly how the algorithm narrows down to possible numbers until it finds the right one. And that's the end of our lesson and the end of our third lesson. And the next lesson we will learn comparing algorithms, block structures, and abstraction and parameters. It will be not hard. You know, our third lesson, our three lessons were not hard. Were easy, and next lessons we will be easy. And see you in the next lesson.